officially introduce a normal distribution and learn how to convert X values into Z values when we have confidential data. The normal distribution, as we saw before, has a bell-shaped graph. Bell-shaped graph. And remember that the graph is symmetric with respect to the mean. And remember that, well, there are always gaps in between the graph and the horizontal axis, horizontal line, which represents X values. So X values are continuous variables. Like what? Like shoe sizes. Like IQ scores. Stock markets. Stocks. Like heights, like weights, and many things we can think about. Heights, weights, and many more examples. They follow a normal distribution. So you remember that we said that the graph has area below it. The area below the graph is 100% or 1. This area is 1 or 100%. Remember that 100% is 100 divided by 100, which is 1. So when you're talking about 1, you're talking about 100%. And this gives us the probability. This area is equivalent to the probability. So when you're talking about the area, you're talking about the probability. Okay, so again, remember that we are using the actual value like X. Very well. So there's a question. Suppose you're working for government and you're a statistician. The government gives you the real data. Well, those data are mainly confidential data. You want to use the result of the data in a research. You want to present them to your classmates. Is there any way we can convert those confidential data into some data that are non-confidential, and you can use the results of the data, the analysis of the data to your classmates? Very well. So one way is to take X value and convert X value into Z score. So we are allowed to take X values, wow, confidential values, and convert them into something new that we call Z value. And convert them into Z value. Okay. Here we're going to use a nice formula to use it as a machine and convert X values into some new data like we call Z. The formula that you're going to use is this machine. You're going to take each X value, find the difference between X and the mean, X minus the mean, and then divide it by the standard deviation. Well, okay. I take each x value. I do the subtraction on the numerator. I use the mean. On the denominator, I'm going to use the standard deviation. This is a standard. This is just a normal distribution. We're going to convert the normal distribution into standard normal distribution. So let me use a different color. I'll try different report for you. This is our normal distribution. Normal distribution. For x values, we take x values and we convert them all into z values, and we have a new name, standard normal distribution. Very well. Okay. So what are the properties of this new distribution? It happens that this new distribution, which we call standard normal distribution, has the exact same shape. Okay. So far so good. It has the exact same shape. It is a bell-shaped graph. What about the area? The area is going to be 100% or 1. So far so good, right? The area, which is 100% or 1. Well, then what happens to x? X converts into z. Guys, when you're using standard normal distribution, your horizontal line is denoted by z values. Okay, well, x is converted into z. What happens to the mean? What happens to the standard deviation? Let us go back to empirical rule. So, from empirical rule, we can divide up a normal distribution this way. Rule says that if you have a normal distribution, whatever the mean is, 68% of the data are within one standard deviation of the mean. 68% of the data are in one standard deviation of the mean. Okay, so it means that if I have the mean mu minus one standard deviation, mu plus one standard deviation has 68% of the data. Okay, not that hard, just an approximation. Mu minus sigma and mu plus so you see that, hey, 95% of the data are within two standard deviations. 95% of the data are in two standard deviation of the mean. Okay. So let's just go further here. 95% of the data, mu plus two standard deviation, and mu minus two standard deviation. So it's going to be 95%. finally, 99.7% of the data are within 3 standard deviations. Often, 99.7% of the data are in 3 standard deviations of the data. These are just approximation using the empirical. Okay. Why we are writing this down? Because we want to convert each of these numbers into z-scores, z-values. Mu plus 3 standard deviation and mu minus 3 standard deviation. Okay. This is from empirical rule saying that, hey, the probability that x is within mu minus sigma and mu plus sigma is 68%, then the probability that the x value is within mu minus 2 standard deviation, mu plus 2 standard deviation is 95%, and finally, the probability or the area below the graph is 99.7%. The data, the values that we have are within 3 standard deviations of, okay. So, what are we going to do? We're going to convert each of these into z values using the formula. Remember that. Z is equal to x minus the mean divided by the standard deviation. This is a machine. You're going to take x values and plug them into this machine. This machine converts x values into z values. Let's see. Let's start by taking the mean. So my x value is equal to the mean. All right. My x is equal to the mean. This is my very first x value. I'm going to plug that into the z. So z becomes x is equal to the mean, so it becomes mu minus mu divided by standard deviation. We get 0 divided by 1 standard deviation, which is 0. So your mean is, I took the mean and I just plugged that into this machine and it gave me 0 back. Okay. So when it comes to standard normal distribution, the mean is always 0. Mean always. Okay, very good. So the next number that I'm going to use, the next x value that I'm going to use is mu plus sigma. Okay. This is for x equals to the mean. Z is 0. Now, if x is equal to mu plus 1 standard deviation, if I plug this x into this machine, what happens to my z value? What is the value of z? Z is x is mu plus sigma, minus mu, okay, divided by sigma. Mu and minus mu, they cancel out. You get sigma divided by sigma equals to 1. So this number, mu plus sigma, is nothing but z equals to 1. So your z is 1. Okay. So as you can see, you are not working with the confidential data anymore. All of these numbers are converted into 0, 1, later on you're going to see -1, 2, -2, 3, -3, and so on. Let's plug in one more number. I'm going to take this x value, mu minus sigma, and I want to calculate the z. So x is mu minus sigma. Z becomes mu minus sigma is my x. I'm going to plug that into this formula, into this machine. Minus the mean divided by sigma. As a formula, I have to write it down. Mu and minus mu, they cancel out. I left with negative sigma divided by sigma, which is -1. Guys, this number, mu minus sigma, is just -1. You can convert the rest of them into z value. You get 2, 3, -2, -3, and these sides are your 0. So the mean is always 0 with standard deviation equals to 1. This is for a standard normal distribution. Again, why we did that? We have confidential data. We have information that we are not allowed to share, but you can take these x values, use this machine, z, and convert them into some numerical values that help you to analyze the data and use it in public without being worried about the actual data being exposed.
Thank you, Kelly. So as you can see here, you have a survey. You're a statistician, you ran a survey, and you found that, hey, on average,